Hi and welcome. This week's video involves a new tool I got that I keep in my pocket all the time, and a lot of people do the same. It's a pocket knife, but this is a different version. It's by Gerber, and this pocket knife uses replaceable blades. Now I know you can go sharpening existing blades all the time, but the problem with doing that is that in this particular case, I cut boxes all the time at work, and that dulls a blade faster than anything, and it's just a heck of a lot easier to be able to swap out the blade real fast, especially when I don't have time to get back and sharpen it. My only complaint about it, besides the belt clip, which I don't need, which I already bent and made it so I could remove it, is the screw to replace the blade is a slot, and I really hate that. So I'm going to make a really quick thumb screw extension to fit in here that'll just have a little piece that's proud here, a little knob that I can unscrew, swap the blade, and get back to work. So first step is just to remove this clip, which I already did once. I put it back on so you can see what it looked like, because I don't really need that in my pocket. And next is just going to be to make a screw replacement. That should be quick and easy, but useful all at the same time. The challenge is going to be to make such a small threaded section, because this guy really is a tiny screw, as you can see. And I don't know that I could turn this on the lathe without making some really small thread cutting tool. So we're going to try and do it in two pieces. A thumb screw portion that'll fit in here and extend above the surface, and then I will find matching threads and put that threaded part into the thumb screw part I make. So hopefully that'll all work out. It may have been a little confusing, but hopefully it'll make more sense when I move forward. To find the diameter, I use pin gauges, and this one is stamped, so it's not a very clean hole, but it's about 0.216. So if I want to make an insert piece that's got a little bit of slop, we could shoot for something a little bit under that. So to find how deep this hole is, I'm just using a depth mic over on the side where the threads aren't. Got to be careful because you got a lot of mechanical advantage, and it's easy to jack the mic up over the top. So this is 1.50 plus 12, so 1.162. So we need 0.162. Actually, we need a little bit less. So next up, got to figure out what the threads are. I think they might be metric. It's true, the screw threads were M3. I'm not sure what the pitch is. It's M3 by whatever the most common M3 is, because I had a few of these. I hopefully have a tap for this. I think I do. So next up is make the thumb screw. First time through, when I measured the depth, I forgot to include the thickness of the blade, so I went back and slid the blade in, slid it over, and then measured the depth. Significantly different that way. Interesting to note that you can buy blades that are not just plain old steel, carbon steel. You can get some that are carbide coated like this one. So cutting boxes, they last a whole lot longer, which is great. We're going to start with center drill, and here's the tap drill. The threads are M3 by 0.5. I gotta say, this mill feels massive compared to this part size. I think you need one of those scaled down watchmaker's lathes, but never done anything this small, but we're going to give it a shot. So let's start with center drill. And I think as far as the drill bit's concerned, I'm going to be fine with the drill bit going all the way through the part, or the threaded portion going all the way through the part. So we're going to go in somewhat deeply. Tapping's next. Here's a test fit. That tap made for some pretty sloppy threads, but they're correct. So next up, dimensioning. This whole part only needs to be 0.35 inches in diameter, and it's only going to be a total of a 1/4 inch deep. It's a really tiny part. Like I said, I've never done anything this small on this big a lathe, or on any lathe for that matter. So new experience, kind of interesting. So we're just going to take this down to 0.35. I'm going to knurl the whole thing, and then I'm going to reduce the diameter of the end part to be the right dimension. So let's start by touching off here. We're going to go in 100 here. I might want to try this again in stainless steel, but for now we're going to do brass. I've chosen my finest knurling wheel, and not finest as in best, but as in the smallest pitch or spacing between the grooves, because I think it's more appropriate for a part of this size. So we're just going to give this a shot. I really have very little experience with this, so this is going to be fun. So there's the knurling. I didn't choose, I don't know, I forgot to look at the spacing on the knurling wheel, and you can set your diameter to match an even quantity of these, but it looks like it overlapped pretty well. There was just one little spot where it was a little bit rough, but not too bad. All in all, pretty good. It's got a good feel on the finger, so that's the important part. All right, next up, we've got to reduce this diameter at the end down to fit inside, and then we just part it off and mount the threaded portion. This is a pretty big blade. It's 100,000 steps of cut. Alright, so quick test, and it's got the little bit of slop I planned for. I gave it like 10,000 slop, so that's good. So now we just need to add the threaded portion and part this off. I've added some Loctite. This is probably a bad idea, but we're going to try and part off the end. I don't think that's going to work. Well, ruined the part. So there were several failed attempts. The first one, I made the mistake of trying to part the screw off even out a little ways. I thought if I did it really gently it'd survive. That was just stupid. It sheared the screw right off, so that was a failure. Second one, everything was going fine, except the screw, the threaded screw, I got a 440 mixed in with my 3mm metric drawer, so that doesn't fit. There's the final product, and I made it a little bit lower profile than this version, and this one does work. So take the blade, pop it in, tighten it up, and we're good to go. Doesn't stick out any more than the clip did originally, so actually it's less than the clip, so it's going to be fine in my pocket, and I can change the blade without finding a screwdriver, which is really nice. So hope you find it useful. Thanks for watching. Hope to see you next time.